This video demonstrates how to conduct explicit dynamic analysis using ANSYS Workbench. This is a crash landing analysis of a space shuttle. This space shuttle is a representative model of the Colombia space shuttle which met with an air disaster. The main topics which are covered under this analysis study are importing the CAD geometry from the CAD modeling package, to do the necessary modifications of the geometry before it is imported for meshing, defining the desired material properties, ensuring the unit system. The current unit system is millimeters, assigning a different thickness for two bodies. The two bodies here are: the first body is the space shuttle body meshed with shell elements, and it has the wall thickness of only 0.5 millimeters. The base body is meshed with the shell elements, and that body behavior is treated as rigid. This is the reason why the base body or the land is not displaying any colors after the crash. The deformation and the stresses are only observed on the space shuttle body because this body is treated as the flexible body. The boundary conditions and the load which are applied on this analysis are: the base body is fixed constraint. The space shuttle is given a velocity in the negative y direction. Necessary analysis settings are made during the analysis, and the deformation happening across the space shuttle are captured in this analysis. Let us begin with the tutorial. This is the side view of the drop of the space shuttle. Let us begin with the tutorial now. Create a new file, that is Explicit Dynamic Analysis, which is over here. Press hold and drag it to the project page. Rename the file as Explicit Dynamic 01. I would like to make use of the geometry of the space shuttle from the previous file. That's the reason why pick on the geometry of the previous file and drag it to the geometry of the C project. You can observe the connectivity of this project. That is, the geometry of B is now connected to the geometry of C. Pick on the model, right-click, pick on Edit, which is going to directly open the mechanical window wherein we can define the end time, analysis settings, boundary conditions, and load, along with the defined mesh. The geometry is now imported into the mechanical. We can observe two bodies, rigid body and a space shuttle. Pick on the geometry here. Pick on the first body and rename the file if desired, or else proceed for defining the thickness of 0.5 millimeters. The second body, let us define the thickness as 1 millimeter. Both the bodies are having the behavior, that is structural behavior, as flexible. Let us make the behavior of the second body to be rigid. Both the bodies are applied with the structural steel material. Pick on the mesh and pick right-click, insert, pick on sizing. Then pick on the body in the selection filter. Select the body, that is space shuttle body. Pick on apply. Enter the element size as 5 millimeter. Enter. We don't want to maintain any mesh refinement across this space shuttle body. That's the reason the 5 millimeter element size should be maintained everywhere without changing the element size. Right-click on the geometry, pick on Generate Mesh. This will take some time to generate the elements on this geometrical body. Meshing is now completed. It can be observed that the space shuttle and the base are meshed with the shell elements with the desired thickness. When we pick on the two bodies, the surface which we have imported for the two bodies will remain at the center and the element will be offset on the either side, which means if we zoom and observe the thickness of the shell elements created, then the surface lies exactly at the center of the thickness. We want this thickness to go on only one side, either top or bottom. That's the reason why pick on the specific body and change its offset type to, say, top. Check for the mesh. We can see that the offset has not been changed. Pick on the desired body, either the spacecraft or the rigid base. Then change its offset type to top. Now it is changed to top. We can observe the mesh for this base is the elements for this base are offset downward. Similarly, we will do it for the space shuttle body. Pick on the space shuttle body and pick on top. Let us see where it is going to offset. Pick on the mesh. Yes, it can be observed that the elements are offset inside, whereas the surface remains outside. If we change this offset type to the bottom, then the surface remains inside and the elements come outside. It can be observed here very clearly. That's the reason. Let us make the element offset inside and the thickness, I repeat, element offset inside and the surface outside. Once the meshing is completed, it is the time to proceed with defining the loads and boundary conditions. We don't have to define a contact for this body interface because automatic contact will be detected in the explicit dynamic analysis. Pick on the contacts, pick on suppress. All the contacts will get deactivated apart from this body interaction. Proceed for the explicit dynamics. Right click, insert, pick on the fixed support. Select the base of this wall, pick on apply. The fixed support has been applied for the base. Under the initial conditions, right click, insert, pick on the velocity. Observe very carefully. The velocity will be applied on the space shuttle in the vertical direction, negative, that is y direction. Pick on the geometry, ensure that the body is selected, select the space shuttle body, pick on apply. Input type is velocity. It should be defined by the components. These components with respect to the global coordinate system, y direction, minus 5000. Or it is as per the user, since it is a test problem. We can observe the direction of the velocity, that is in the negative y direction. The indicated arrow will give clear indication of the direction of the velocity. Pick on the analysis setting. The very important thing is what is the end time. This end time varies with problem to problem. Let us enter 0.0007. Enter. Those many seconds. After those many seconds, the run will finish. Proceed for the output controls. Enter the number of points as 75. Enter. Once the explicit dynamic parameters are defined, it is the time to proceed with the solution. Right click on the solution, pick on insert, pick on the deformation, pick on total. Right click on the solution, pick on solve. The solution process will begin. Pick on the solution information. Enter the update interval less than 2.5, say 1, so that the update can be seen at a faster rate. Pick on the solution output and select the energy summary. After the space shuttle has impacted the land, its velocity should go to minimum and its internal energy should go on increasing. The kinetic energy of the body will move towards close to zero. It can be observed from this graph. It is an understanding that the kinetic energy of the space shuttle is coming down, which means it has already crashed the land, and the internal energy highlighted in the red color or the pink color is go on increasing gradually, which means the elements of the space shuttle are getting deformed and storing the energy in them. After some interval of time, the internal energy and the kinetic energy are going to intersect with each other. This solution process will take a time depending upon the end time specified as well as the number of points. The number of elements and the nodes which are present in this particular model can be recorded from the statistics of the mesh. We can find here under the statistics of the mesh, it is 14,924, the total number of nodes present, and elements are 14,841. Observe the different views of this model. Right click, view front. Right click, pick on view, pick on right. The space shuttle is oriented at an angle of 10 to 15 degrees with respect to the horizontal. Let us go back to the solution information and pick on the energy summary. Internal energy and the kinetic energy are coming close together. Once the solution is completed, we can observe the graph in the following ways. The x-axis of the graph is time. The y-axis is energy. The kinetic energy of the space shuttle will start reducing, and the internal energy of the space shuttle after the impact will go on increasing. Both the curves, that is internal energy of the spacecraft and the kinetic energy of the spacecraft will be a symmetric fashion, and the total energy will be plotted like this. This is total energy. Once we get the graph in this desired fashion, we can conclude that the solution is complete. This is called as energy summary. We can observe the deformed behavior of this model now. Pick on the graph, pick on animate. Switch on the element types. Thank you for watching this video. For more videos, please subscribe my channel by pressing the subscribe button just below this video. Contact for projects and online training through Skype to engineeringtutorsdesk@gmail.com. Please note my Skype ID, Engineering Tutors Desk. The website is https://sites.google.com, site FEA Engineering Design. Thank you.